recorded. So the next topic we're going to study is the skeletal system, bone and bone tissue. Okay, I started to mention to you that every bones in the body is an organ. The humerus is an organ. The radius is an organ. It's not your typical organ you think of, like, you know, the kidney or the liver or the heart. But the bone is an organ because it has more than one tissue. What are the tissues in your humerus? Bone tissue itself, specified connective tissue, blood, and if you break your bone, you feel, you know, very painful. That's nervous tissue. And it's to provide covering, so that's epithelial tissue. So every bone that we know, we look up, is an organ. So together they form an organ system. In this case, it's the skeletal system. I think some of you have already seen this. In terms of bone, there's different classifications of bone. Bone, typically we see them if they're you know, squamous like in terms of cell, we call that flat bone. If it's more like, you know, this, then it's known as long bone. So long bone, like your humerus is a long bone because, you know, height-wise versus the width is very long. But also at the same time, your metatarsal, this is considered long bone too, because it has the same structure. It's not because we call this long bone, it's long, and this one is short. No, long bone will always have the feature, and that is the width is, you know, narrow versus the height, for example. That's long bone. Short bone is more like this. Okay, so more like cuboidal cells, if you will, with the width and the height is almost the same. So all these right here, your carpal bone, considered short bone. Irregular bones, you will see this is very typical of, you know, your vertebra, a column, so lateral view of a bone, vertebral column that looks like this. This is a spinal process. It's very long. I know that is your thoracic vertebrae, for example. So these are the really, most people consider these are the four class of the bone. Sometimes you might see them, the only place that you might see them, the bone that look like a sesame seed, so we call that sesamoidal, like that. And the only sesamoidal bones in our body is patella. Let me show you a little bit. And sutural bone, we're going to talk a little bit later on about joints, and one type of joint in which it doesn't move at all, we call that suture, like in the cranium. And so you might have, say, you know, so that's, let's say that this is the front, sorry for drawing, front, and the frontal bone. Okay, so you can say, oh, that's coronal suture, that's just sagittal suture. There might be a bone that sits in here like this. So we call that sutural bone. And then the next slide will show you that characteristic. Here's a sutural bone that you find in this lambdoidal suture. Typically, irregular bone has different shape. And one way to tell that this is the lumbar, because the vertebral foramen is more triangle, very similar to the way that cervical vertebrae will have this triangle. The lumbar, the thoracic, the vertebral foramen is actually more round. If you guys want to learn more about this bone. Are these carpal bones are considered short because they're kind of like cuboidal in that sense, like that. Okay. Long bone, structurally, you know, all these, your humerus, this one right here is your radius, your ulna. Flat bone are like your parietal bones, okay? And then your patella is the sigmoidal bone. Here, just show you the same suture bone. You see that? I mean, a lot of the just description already. Irregular bone. I think there's 100 and some slide. I'm not going to go all of them today, but we'll see how far we can go. Short bone, flat bone. So most likely, if I'm going long bone and sigmoidal bone. So probably like one of the exam question might be, I give you one of these bones that you use, right? That you've seen before. Like, oh, the femur. How do you classify the femur bone? Is it short bone, long bone, irregular bone, sigmoidal bone, suture? What? It's in the suture? Your femur is in your suture? Come on. It can't be. Okay? And although we try to, get the lab and the lecture to be, similar within a week apart, but because of all this craziness, I think you guys having a test already on the bone and in the lab. Well, some of you are, and then we doing a bone in lecture now. And that is because we spend a little more time in chemistry and the cell, but that's okay. We'll catch up. The reason why I brought this up because some of the bone marking. One of the students asked, there are so many names and they're very similar in different bone. Well, yeah, they're very similar because they're just the naming, identifying the marking. So some of the marking might be like if there's a hole, we already know it's foramen. If it's where the muscle might be attached with or ligament or tendon attached to muscle, we call that elevation or projection. A groove is depression. This one is good to tell you. A lot of bone will have sinus in them. Right? So sinus is typically it's just a space filled with air, and the frontal bone has sinus. The sigmoidal bone has sinus. The maxillary has sinus. Usually they have airs in there, and sometimes will have a surface area that will have lining with the mucosal kind of membrane, so that if you're normal, there is, the cilia is moving these mucus around. And if you smoke a lot or you have an infection, you might interfere with the cilia. So the mucus get stuck in there. And so you develop what we call it sinusitis. Sinusitis. You can blow it out, hopefully it's better, but certainly, particularly the sinus that goes up in the ethmoid, it could basically block the sensation from the olfactory bulb, so that's why you can lose the sense of smell when you have congestion, if you will. Okay. A hole is foramen, we'll talk about that. A fissure, it's a deep furrow, if you will. Meatus and canals, sometimes used similarly in a sense. It just means a passageway, right? I know the temporal bone, you can say, oh, there is a external auditory canal, sometimes known as the meatus, external auditory meatus, or acoustic meatus. In the nasal cavity, you can see that these are created a passageway here. So these two up here are your superior and middle, not nasal concave. And this one down here is inferior nasal concave. This one and this one. But between them, they create a passageway, a meatus, so air can flow through, for example. A ramus is a good word to know. That's usually meaning that a bone that has an angle, right? So your mandible will have these ramus here that sends the projecting up as part of the temporomandibular joint. Okay. All right, so similarly, you can see that particularly long bone, you see this a lot. This is known as the crest, okay? A ridge, an iliac crest, very prominent in some people. During the summer, you might see them check, particularly if they wear the bikini, underneath that, the crest is showing. Trochanter, large rub projecting. The neck, of course, this is the head of the femur. You see something like a condyle, medial condyle. This is medial because it's in line with the head of the, right? And this is a lateral epicondyle in line with the greater trochanter of the femur. A trochlear, a condyle. A trochlear, you can see here. A trochlear is really like a scroll. That's what trochlear would mean. It looks like that. That's a trochlear. Okay. And so the olecranian fossa, and in the back, you may see a fossa here. Fossa depression. So here, should be the trochlear right here, and then this is your condyle or trochlear here. So that the C notch of the ulna looks something like this. Okay. And that can fit into the trochlear, and it forms as like a hinge joint. Okay, so that's the marking on bone. Bone tissue, in fact, we see it's specialized connective tissue. But when you look at bone, I like this picture because it shows you two important things of long bone development. Okay, so keep this in mind. There are two processes that involve in making bone. The processes are either intramembranous ossification, intramembranous ossification, or endochondral ossification. Okay. So if you think of most of the bone, easier way to think of it, bone from the neck down, okay, is usually made by this process known as endochondral ossification. What does the word chondro mean? Anybody know what does the word chondro mean? Abdu? Oh, Alice. Can you turn off your microphone, Alice?
Okay.
Abdu. What does chondro mean? Does anybody know? Adriana? Does anybody know what endochondral means? Endochondral. Cartilage, yes. Thank you, Janice. Cartridge. No, cartilage. And you mean cartilage. That's good. That's what you should be thinking, right? You should be thinking. So the way that the long bone. This is an example of long bone here from the neck down. In the fetal skeleton, for example, start out with cartilage first, and then it get ossified. So all these long bone right here, they start out with cartilage, and then it get ossified by ossification, meaning it taking calcium and phosphate, and it turn into bone that we know. Okay. But usually at the end of the long bone is not ossified, so it's remain as cartilage. And this bone typically will show you two nice things. The region that is outside here, this is known as the compact bone, and this region here is known as the spongy bone. So you have your compact bones, your spongy bone, if you want, you can say, okay, from here down, that's the diaphysis. Here's the epiphysis. I'm going to show you a little bit. And the neck right here. Okay, so a little bit about functions of bone. We already know what bone does, and that is, cranium protects the vital organ like the brain. The rib cage protects the lungs and the heart. Um, it does that. It serves as an attachment for muscle, so that is part involved in movement. It gives you the framework, right? Because without the skeleton, you guys probably like a slug sliding along. But more importantly, or the one of the functions of bone is that all your blood cells are made in the bone marrow, long bone marrow, okay, are made there. And bone, you think it's hard like this, and that is it's you might think of it as stagnant, but it's not. It's dynamic. It's living in the sense that it's constantly remodeling. Meaning that if you have a lot of calcium, you're going to put store that calcium in bone. And if you need calcium, you take it out from bone, right? And so it is a storage for minerals and metals, for example. So magnesium, phosphate, sodium, potassium, particularly calcium is stored in the bone. All right, bone tissue. A good word to know, and that is what you see here, the structure here, particular bone tissue. When we talk about bone, this is the compact part of the bone. Okay. Someone have a question? Okay. So this is the compact part of the bone, and the compact bone will have what we consider as the functional units of bone. What is the functional unit of bone? Okay, and the answer you guys should know by now is osteon. That will be your next exam question. So the functional unit of bone is the osteon. Can't move this. It's the osteon. Okay. And this is what an osteon is. It has a central canals here. These are perforating canal, also known as Voltzmann's canal. We already talked about. Alice, can you turn off your microphone?
I don't know where to.
Below the slide, you see there's 4 icons there, the camera, the guy's raising his hand. On the left of the guy raising the hand, there's a camera. On the left of that is the microphone.
I cannot. Let me try it.
Okay, all right, let me see if we can move on. Okay, so good word to know is osteon. What's an osteon? That's a functional units of bone. And you find this in compact bone. You don't see it too much in the trabeculae, although they're a structure that look like an osteon. And the osteon is made out of these lamellar plate, which I'm going to show you a little bit. All right, lamellar plate. Okay, so the structure of long bone, you can read it there, but actually it shows you nice here. So you have a long bone that looks like this, right? That's bad. I don't know why I need to draw the structure. This part right here is known as the epiphysis. Okay. There's another one down here, it's epiphysis. The middle part is metaphysis, same thing. And this region's right here, right there, is known as diaphysis. That's where you see a lot of these medulla, or the marrow is found here. Okay? This is the medulla of the bone. Medullary canal, if you want. And then there you might have the red marrow. And the red marrow is involved in making your blood cell that you see here. Okay, so here's an actual bone that they cut it and shows you a nice compact versus the marrow. And down here is the trabeculae or spongy bone. Okay? Spongy bone would have right here. This is known as trabeculae. Okay. That's the trabeculae. This is an interesting thing right here. Okay? It's called the epiphyseal plate. The epiphyseal plate. When someone look at this bone and they see the epiphyseal plate is closed like this, that suggests that this bone have already reached its maturity. That it doesn't grow longer anymore. In children, the epiphyseal plate will be big. It will be like, the epiphyseal plate will be like this. You can actually see it, but when it's closed like this, it already reaches adult. So I think most of you already have your epiphyseal plate is closed, right? So when you need to grow, and what hormone stimulates this bone growth is usually the growth hormone. Growth hormone. And if a child, for whatever reason, produce a lot of growth hormone, then the bone will go longer. Right? Will get really, really long, like this. So it can lead to gigantism. And certainly a child that has no growth hormone, the bone doesn't grow as much. And we call that dwarfism, no growth hormone. If it's too much, it's gigantism. There is a condition, however, if adult, their bone, they have a tumor in the brain, right? And so once that reaches the adult, the epiphyseal plate is already closed. But if you add a lot of growth hormones to this, so the bone is actually going to get thicker. Like this. It's much thicker. So you can see the hands are really thick. And the condition is known as acromegaly. Acromegaly. I don't know if you guys know Andre the Giant. You can see Andre the Giant. You usually have the hands is really big. They also have protruding jaw, if you will. And that is probably because he has too much growth hormone as an adult. And so the bone will get thicker. They don't get longer, but they get thicker. Okay. All right. So good thing to know that most of the bone from the neck down is made by the endochondral ossification. But bone from the neck up, a lot of these bone, particular flat bone, is made in a process known as intramembranous ossification. Intramembranous ossification. So there's two different things, right? Bone from the neck down, they usually start out with the cartilage, hence the name, the endochondral ossification. But bone like up here, They usually are not. They they start out differently. They start out with mesenchymal stem cell that condense to become osteoblast that lays the bone. But the telltale sign that you see in the case of these flat bone that is made in endochondral ossification, and that is you can think of it as like there's two compact bone, right? There's a compact bone outside, there's a compact bone outside here in the outer surface and inner surface. And in the inner area here, okay, it's more like trabeculae or spongy, right? And we call that diploid. Okay, so when you see the word diploid, think of it as it's made by the intramembranous ossification. In fact, I will probably have I will have the 5 steps that is involved in mating, making the bone by the process known as intramembranous ossification, but you also need to know it as well. Okay, and start learning those. And there's 6 steps that are involved in making the endochondral ossification. Sorry, so this is the process made in intramembranous ossification. All right. Okay, why don't we take a 5-minute break starting from here? I'm going to stop the recording